All right, cool. Hi, I'm Zaki. Why don't you guys introduce yourself?
I'm Uma. I'm the co-founder of Succinct. We're building a ZKVM SP1 and a decentralized prover network to make ZK very easy.
Hi, I'm Illia, co-founder of Near Blockchain for AI.
Hello, my name is Robert Drost. I'm CEO at EigenLayer Foundation.
Hi, I'm Zach Williamson. I am the CEO of Aztec, a privacy preserving layer 2 for Ethereum.
And co-founder.
And co-founder, yes.
Don't forget that.
Yeah, I forget a lot of my old
I
age.
wish I could say I was co-founder with Ethereum. Sorry,
Cool. All right, why don't we dive into the topic? Maybe the first place is to define what the ZK endgame could mean. What does it mean for ZK to be the endgame?
I think at a very simple level, I think this is 100% true, going to happen, or 99% is that every rollup on Ethereum is going to be a ZK rollup. I think probably everyone here agrees. Maybe that's not that interesting to debate. I think almost every chain will be a ZK chain. I think the endgame architecture is you have a scalable DA layer where people are coming to consensus, and then everything on top is verified with ZK proofs. Maybe that's a little, I don't know if everyone here agrees with that. So yeah, I think most chains will just be ZK.
Yeah, I think maybe to up the level, if we think from a computing perspective, we started with personal computing, then we went into cloud, where effectively we gave all of our data, all of our computing to somebody else. And with blockchain, we've been trying to kind of take it back, but it's still highly transparent, right? Everything that happens is public, and it's extremely expensive. And so if we talk about endgame, and we can discuss what are the interesting properties. To me, it's how does computation, all of the computation, transforms back into where you own, kind of user own this computation, right? This can be local, this can be confidential, this can be verifiable. Those are effectively different. Confidential and verifiable properties, local or remote is the execution environment. I do think actually confidentiality is for general cases actually more important, right? If you're computing over somebody's data, you want confidentiality. If you want, doing AI, if you're doing medical, finance, but also if you're doing generic kind of social, you're sending somebody a message right now, how do you know it's actually confidential and not leaking everywhere? Verifiable obviously gives you a lot of properties as well. And so ZK gives kind of indeed the verifiability, but we're still missing the confidentiality, and that's why I think ZK is a part of the end game. It's not the full story.
Okay, that's great. I need to make one correction. You said that we start off with personal computers. We actually started off with mainframes and timeshare, then we went to personal, then we went back to cloud, and now we're trying to go back to personal blockchain. So now 2 full cycles.
We're going personal and cloud at the same time, while local, verified and
But
private.
it's now it's personal what's happening in the cloud because it's confidential if you want, and it's verifiable, so it's as if it was happening on your local device. So we're actually, what is this? This is like cloud simulation of personal computing. That's what we're moving to. Okay, so yeah, I think there's different end games. For sure, ZK is one of the most important parts of the overall end game. I think if you just look at the fact, though, of what is the performance, the capital expense, and the operational expense overhead of ZK, which Uma and I were doing some last night, I think across the 3 dimensions, it comes out to almost $1 million. And I think Uma's super smart, and so I think she's going to get rid of 10,000 of that. So, but I think that there's still going to be probably 100x type scaling. So that tells me that there's use cases where it's going to be terrific. I completely, violently agree that having everybody rerun VM execution on a blockchain is going to go away. That's just frankly going to go away. Optimistic running and the long delay for optimistic proofs plus all the exit conditions of censoring, exits to L1 and everything else, that's going to go away. I think, though, that, yeah, there will be cases where TEs are good enough. There'll be other cases where people just are okay with even plain text. So those are going to be around. I think one big class, I mentioned this the other time we were talking, there's like, ZK lets you be the end game. It can be the end game for everything where the cost is acceptable, where there is a objective, non-interactive mathematical proof of what you want. There are very important sets of what you want to establish with crypto economic security that are like collective human beliefs. And those can't be ZK. So that's kind of my division.
Yeah, ZK the endgame for what? I guess.
You get to define it. So make
Wonderful.
your steel man.
Yeah, so I'll steal it because I think that privacy is key for this. Where ZK for scaling, it's important, but there are other ways of achieving it. I do agree that eventually everything is going to be ZK rollups, but in my opinion, like the valuable, this becomes valuable when you reach some certain win conditions. For example, when blockchain infrastructure replaces global financial infrastructure, that will be an end game worth chasing, and that's going to require ZK. It's going to require privacy tech. Another end game will be effectively enabling composability within Web 2 applications in the same way that you get them within Web 3 applications. For example, you will be able to seamlessly pipe data from, say, Facebook into another social media application without the consent or participation of Facebook, using zero-knowledge proofs, breaking down effectively these centralized data moats that Web 2 companies have, and creating forcing through a much more open internet, where companies can no longer rely on monetizing because of data moats and have to find other sources of revenue. Yeah.
So I guess like maybe a good thing to like discuss and to frame for the audience is, okay, what are the barriers to any of the end games? Whether it's every blockchain and every interoperability protocol using ZK to, we have put global finance in ZK. So maybe we could like talk about progress, talk about like where we need to go, talk about like where the numbers are in terms of how expensive it is to do these things, like what is the gap between running validators and like replicating and recomputing things?
Well, I think already today there's kind of this myth that ZK is expensive, and I'm not saying ZK is, has 10x overhead or something very small from running it on a normal computer. It's much higher than that. It's like definitely closer to $1 million. But if you look at, for example, like the amount that Near, for example, pays its validators or stakers, I think it's probably in like the hundreds of millions of dollars a year in emissions. Ethereum is billions of dollars. Solana's many billions of dollars. They recently had a proposal that actually failed to lower it. And if you think about all those protocols and if they were ZK instead, the price of proof, like if you paid me $100 million to prove, I would happily generate all those proofs and verify your entire chain. So I think we always need to be comparing to what ZK is replacing. So the truth is you can think, theoretically, spinning up a bunch of nodes across the world, even 100 or 1,000 is very cheap. But in practice, it actually takes hundreds of millions of dollars, if not more. And that's like real outflows of like giving people a coin, and they sell the coin to pay AWS to run the node. So I actually think ZK is already very cheap, and people just need to wake up to that fact in many ways.
So the cost that layer ones are paying is not because of the execution; it's because of DA and kind of overall like non-reversibility of the consensus. And so like even if there's no execution done, right, you still need to pay that cost. And similarly, if we switch tomorrow to ZK, which we definitely want to as soon as it's performant enough, it's not that we can like now reduce payout to validators.
Yeah, I definitely, you still need to pay for consensus, but I think the endgame model of like Ethereum's architecture, or like Celestia's architecture, where you have one global layer that's coming to consensus and is very cheap and optimized, and then you just pay that layer for consensus, and then you scale execution with ZK, makes a lot more sense to me than the Cosmos model, sorry Zaki, where to get consensus and verifiability, you do it all at once. So you have to spin up your own validator set that's coming to consensus, and also it's like ensuring the execution's correct at the same time.
Yeah, so I mean, I agree with that vision because NEAR is effectively that. NEAR is, consensus plus DA, and then we run execution. We already switched to stateless validation last year. So stateless validation means the validators actually don't need to track the shards. They don't need to track the state. They can literally join, validate, and leave. And right now we're sending them effectively the block with all the state, and they need to re-execute. But indeed, as soon as the ZK proof is fast enough for the low latency we're actually optimizing for, we can switch to that, and this will be that end design. So I totally agree that this is kind of where this is going. And indeed, I mean, we've been discussed how kind of this consensus DA can actually be shared between multiple blockchains from the emissions perspective. So I think that is definitely on the road. Again, the question is latency performance. I mean, you kind of mentioned some of this, but I do think we probably need a hardware that actually is optimized for both the VM and ZK proving at the same time, right? So probably an ASIC that can run RISC-V plus ZK proving in parallel. So you can actually execute and produce that. And so getting that and deploying that to enough validators, right? To block producers might be, a logistical complication. But I think as soon as we have that kind of normalized, so probably 2-3 years from my perspective, we can probably have that transition.
Yeah, I'm going to jump in here also. I think it was 4 years ago when Sriram was first chatting with me about the idea of pulling the security out as its own layer of a chain. That led me and Sriram to talk about it, and we kind of did a Goduncan experiment where we were imagine in the future, I didn't know you back then, but really smart cryptographers figure out how to put together ZK, and now computation is free for a chain. And then imagine that we get the bandwidth protocols worked out and incentivized, and bandwidth, as we know, is basically free. It's 0.042 cents or something per gigabyte that's being transmitted. And arguably, it could even be lower than that. It's sort of, probably a bit of markups on that. I met somebody here who's doing a DPIN protocol where they're going to essentially take for every fiber that's going under the ocean, there's another 99 that are just sitting there dark. And mostly it's there because nobody's figured out exactly how to put it into a network and use it. And that's going to be a DPIN Web3 thing. So the bandwidth is going to basically be free. And Illia just talked about this idea about blobs. Moving around state blobs, the bandwidth is free, and then nobody has to store stuff anymore. And similar to ZK, you have one proof of the computation, and then you have one proof of the state data gets passed around. So now everything is free. So then it's sort of why is there gas anymore at this point, on Ethereum? And, this is sort of the conclusion I came to. I mean, there's some level of a DOS type vector around it. But the bigger one is I haven't heard this actually. You didn't say immutability. You called it the non-reversibility, which is good. I think that's more understandable for a lot of people than immutable. But so to make something non-reversible, nothing in the world is absolute. Nothing is not reversible. It's not reversible at some cost. What is the cost? It's the amount of stake that has been put down that people are willing to lose if the operators cheat and start double signing or going to an older block because the double spend attack is worth it. And so somehow you have to pay people to encumber assets and put them at risk with loss of capital. And so you're going to have to pay for that. And so that was our conclusion 4 years ago, which is blockchain is probably going in a direction where the one final unchangeable cost is going to be you have to pay for cryptoeconomic security thresholds. So I think, but I don't want to fully contest your point is right, that right now we also have to have validators doing this useless computation. And they're doing that because we also need to build up this idea that we're not having, bogus information sets going forward. And different chains do it differently. Ethereum wants Raspberry Pis to be able to do it. I think Mega ETH is in a good middle ground, right, where they do their computation on beefier servers than even Solana, but then their end game roadmap is exactly this, to generate ZK proofs, and now you have like trivial validating by 100,000 people. So so I think the cost will go down, but I think the final residual that we're going to have left over is just having to pay for crypto economic security.
Yeah, I want to tackle this question from a slightly different angle, which is that of privacy-preserving applications and privacy.
That's why
apps.
we invite you.
Thank you.
We got to have privacy on the panel. None of
yes.
us are as...
And to give some concrete numbers about, how do we make this practical? I'll try to be fast. So if you want to, say, prove a passport signature or prove an email with our technology, inside a web browser, that'll take you about 5 seconds, which is good, but it's not Web 2 type of user experience. And so to drill down, what needs to be done, it's all about complexity. Complexity. Right now, if you want to build a privacy-preserving application, you as a developer, you're going to pay a very high complexity overhead because there's a completely new different technology stack to learn. And then your users are going to pay a high complexity overhead because they have to wait for their transactions. You have to wait 5 seconds. What you're building might not be very seamlessly compatible with a lot of other parts of the Web3 ecosystem because privacy is very novel. And so where else can that complexity be paid down? We don't want the user to pay it. We don't want the application developer to pay it. So the mathematician and cryptographer can pay it by developing more efficient, more advanced cryptography protocols to prove more with less computation. The software engineer can pay it by implementing state-of-the-art cryptography much more efficiently, utilizing CPU resources more effectively. And the protocol engineer and protocol architect can pay for it by creating transaction networks like Aztec, where using privacy technology is seamless, where you have high-quality tooling and an ability to integrate within the wider Web3 ecosystem more effectively. And enormous amounts of work needs to be done on all of these verticals for many, many years to come.
So maybe let's pivot a little bit to, is the security of ZK a significant barrier to getting to the end game? Like, maybe ZK will be fast, but what do we have? What needs to happen for it to be secure enough to get to the end game, and what can we do about that?
I think formal verification is pretty interesting and very promising. So I actually think in 2 years we're not going to have like circuit level soundness issues because even today there's like a team we're working with where they can prove the determinism of SP1 circuits. So they can basically prove for a given input there's a deterministic output. And if you run enough test cases, it basically guarantees that your circuit isn't under-constrained. Obviously, you can have bugs in other parts of the proof system, like the end-to-end system is very complex. There's things like recursion and a bunch of other logic. But I think people often worry about circuit bugs, and I actually think that's going to go away even in like 6 months. So that, yeah, I think security, and then for security, you can always have multiple proof systems. You can have multiple factors. You can have SP1, you can have TEs, you can combine those things together, like stage 2. For example, in Ethereum's roadmap advocates for having multiple proof systems, whether they are ZK or TE. Vitalik recently wrote a blog post about that. So from my perspective, I think security, there's like practical security, there's theoretical, like 100% bulletproof security, ivory tower security. I think practical security, we're going to get there. If not, we're already there with ZK plus TE today, and like with a lot of the formal verification efforts on a practical level, we'll probably be there in the next 6 months.
Okay, what does ZK plus TE actually do? Because I don't think anyone understands.
Or what is ZK plus TE? You have a computation you want to prove, you generate a proof normally, and you also generate a proof of that computation in a TE. And so you have a TE proof where you have basically a proof signed by the hardware. You can think of it like the hardware as a private key, and they're signing that, when you run on a normal computer, you get this answer. And then you have a ZK proof, which is a cryptographic proof. And so if your ZK proof is broken because there's bugs in the proof system, then if you're verifying both a ZK proof and a TE proof, you also need your hardware to be compromised to have an invalid result. And the reason people, I guess, don't like TEs, I'm curious, Zach, for your opinion on TEs, because often, I guess privacy applications, there's protocols that have popped up that are using TEs, is that people think you can't store billions of dollars in a TE, which I generally tend to agree with. And TEs have had a history of being compromised and have various attacks. But I think if you have two factors, then it seems quite reasonable to be able to rely on like 2 of 2 security.
Yeah, I mean, from our perspective, you right now, and like from the cost perspective, even long term, anything that you need to do where you need AI, data processing, large scale data processing, like anything like Web 2 scale, databases, etc., TE is a really good solution. And all the attacks on TEs are all about effectively extracting a few bits of information based on so-called side channels attacks, where you kind of can observe some kind of different behavior that's happening in the CPU. And if you're processing like gigabytes of data with that, it's really hard to kind of extract a lot of statistical information. But indeed, you should not rely on TE alone to secure billions of dollars, and that's why we have blockchains and smart contracts, which can then provide any additional rule sets and verification, be that ZK or be that more kind of specific restrictions around like, hey, you shouldn't spend $1 billion in one transaction or whatever else, right? And you can have cooldown periods and anything else like you want to secure your money with.
Yeah, so about TEs, basically just to reiterate that, I think long-term storage of private keys within a TE is extremely bad news. And given the multiple previous attacks on trusted execution environments. For people who don't know what a TE is, it's effectively a piece of dedicated hardware that will run software, where the idea is that no information leaks out of that device. Even if you physically have physical access to that hardware running the program, you cannot spy on it, you cannot see what it's inside its memory. And so in theory, you can use them to run very sensitive, secretive computations. In practice, they get compromised and attacked a lot because they're complicated to build. I think they're fine for the kind of type use cases that have been talked about here. I just don't think they're very good they're not good at all for storing private keys long term. I do think that this conversation about security is, at the risk of being provocative, I think it's a little bit not serious enough, not rigorous enough. And I'll give an example. So for example, people talk a lot about redundant proving systems. Oh, we'll just prove the same thing with 2 different proving systems. We are already, people in this panel, dealing with an absolute nightmare of complexity with one proving system. You will use redundant proving systems in the same way that your typical layer 2 will decentralize. They all talk about decentralization. They don't decentralize because it's hard and they don't want to, and their user base doesn't want them to either. Similarly, you're not going to see redundant proving anytime soon. It's too complicated. Maybe TEs, but even then I'm kind of skeptical. And I have a very different...
I mean, that is in production. ZK plus TE, multiple rollups are running with that.
Okay.
And also with SP1, we recently added a feature where it's literally one line of code.
One line of code.
So just one line of code, you also get a TE proof.
Okay, I'll take that back. Maybe with TEs, but... okay. For Aztec, things are very different. And that's because Aztec is decentralized from day one, completely, which means that if there is a bug in your cryptography, if there is a bug in the implementation of that cryptography, then anybody can use that to attack the network and steal user funds, just like if there was a bug on Ethereum. For most layer 2s, most applications using ZK, this is not the case. What happens is that there is one sequencer that makes that composes the transactions. There is one prover that makes the proof, and the company building the ZK solution runs the prover. Therefore, if there is a bug in the prover, it actually doesn't matter that much because an attacker doesn't have the ability to make proofs. This is not the case with Aztec. If there is a bug in our cryptography, it can be used to steal hundreds of millions of dollars. And so for us, to answer your question, it is an overwhelming concern, and it slows us down immensely. One of the reasons we haven't launched yet is purely security, and having to perform a security audit on a dizzying array of brand spanking new cryptographic primitives that have not been seen in production before. And I think that this obviously will all get solved in time, but not on kind of the typical timeframes that people would like. As in, I feel like the only thing that really secures a cryptographic network is time. It's time in production, time being used by people, time being seen and observed by people without it being attacked. I think one of the things that we can rely on when it comes to security is that we have a very, very high quality set of, like this community has an incredible number of cryptographers, researchers, security engineers that are all white hats, and they will act in good faith, and they will report bugs and problems as soon as they find them. This won't last forever. Eventually, there's going to, I would be amazed if North Korea isn't already brushing up on its zero-knowledge cryptography and learning about it. And we are not far away from black hats being able to actively identify and exploit cryptography bugs. So the window of being able to rely on good faith is rapidly closing.
So I wanted to expand on form verification kind of within this concept, because I think, first of all, for example, state actors that are attacking, it's actually easier to compromise everything else, not the cryptography, generally, right? As we've seen historically, it's way easier.
Sorry to jump in, but when I mean cryptography, I don't really mean like the actual mathematics of the paper. I mean the implementation of the cryptography.
Yeah. So I think first of all, like for example, to your point about the rollups having single sequencer, if they are open to effectively anyone submitting proofs, right, then effectively that's the same as if it was decentralized from perspective of somebody can submit malicious proofs withdrawing all the money into their account. That's why you kind of need like 5 levels of guardians in any of the ZK VMs right now, and you still have an hour delay. That's why alternative layer 1s are still way faster than anything rollups can offer. But I think the fundamental actually, again, reverting back from a user perspective, I want guarantees, right? Like all of these current systems actually, they, as you said, they guarantee, like they have, talk about security. They hope there's like enough audits and people looked at it and nobody done it. But there's no actual guarantee from my perspective that when I put money into the smart contract or I transact with this chain, it's not gonna, in implementation have a bug that effectively is invalid state transition from my perspective, right? Unless I review every single code myself, right, which users cannot. And so I think there's a fundamental framework of form verification where you can, as you send a transaction, as you interact with the blockchain or any service for that matter, you attach the precondition that you care about. And the service, the smart contract, need to prove it to you with whatever other things it uses, whatever, as approvers and systems, etc. It needs to prove to you that it indeed satisfies us. And I think if we can actually get to that, that will be the way we actually get like actual security from individual perspective. Now, we need easy tooling for specifying these preconditions, etc. But the easiest precondition is don't lose my money, right? I'm putting LP position into some smart contract. Like I should be able to withdraw at least as much money from this or whatever the impermanent loss conditions are. And so this is where form verification and ZK will be really important, because you can actually run form verification, use AI to construct the proof for specific preconditions, and then ZK it proof back to the user. So I think there's a lot of interesting kind of what is the security of the future looks like. And I think this is actually fundamental because every single line of code written by humans have bugs. Like it doesn't matter how much we review, right? We keep finding issues in like fundamental, like Go networking stack had a bug, for example, that you can pretend to be in the local network, which for Ethereum client means you can access the RPC, and if it's a validator node, you can effectively get the private key. So there's so much complexity in code that unless we actually prove the whole stack, we're gonna keep having vulnerabilities across the whole stack.
Formal verification is the end game.
Yes.
Yeah, I would definitely say it's good to do a career in security. I wanted to just make 2 modifications because I think everybody here has made good points. Uma, you get the I think the winning on that one for the fewest words with the most impact out of what Zaki and Illia and you just said. One thing I wanted to add, you said this statement about time is the only thing that gives you, longer term kind of trust. I think it's actually like some kind of integral of time times a function of the value that is possible to be stolen. And like maybe that function of value is something that is, sublinear, but it may also be that it's exponential, right? Because the effect of there being $10 billion to steal versus 100 may take people who would never even bother to look at it and bring them in, which means that, it's going up higher.
That's true. Yeah, I mean, I was assuming that Aztec would be extraordinarily valuable. So it's a fixed parameter in my reasoning.
Yeah. One other thing I wanted to just say, I don't know if we're willing to do this. Before we came out, we were having a conversation, and it seemed like on the panelists, some of us have different views about the end game for humanity. And in some sense, like how ZK as an end game is affected by like what has value that humans will do, humans in combination with AI. And maybe let me just kick off, assuming that that's a reasonable moderation thing.
That was where I was going next.
Oh, okay. If AI is not going to steal your job, Zaki, Robert's going to. So I was going to make one comment, which is, on the one hand, people generally think that ZK-ML is like super impossible to actually do. I'm not the expert, but like talking to people who are an expert on that. Michael Gao is the name of a founder of a hardware company called Fabric Semiconductor. Anyway, they're doing verifiable processing units that are eventually going to probably be on the order of like almost 1,000 times better on like cost and performance metrics versus GPUs. It ends up there's just a lot you can optimize when you make an ASIC specifically for large cryptography primitives versus trying to take a 8 or 16 or 32-bit floating point GPU and repurpose it. So, but Michael was telling me that, like a proof system that previously I thought wasn't very practical, I think it's called GKR. So Daniel Shore and the Modulus team kind of gave up on it. But Michael was saying when you get to really large foundational models and the size of the matrices are like 256, then the constant factors that Daniel and Modulus thought made GKR not effective, they become really tiny compared to the n cubed or whatever type operations that you have in ML. And the beautiful part of GKR is that you run the computation, the machine learning plaintext, at full speed, at the cheapest possible cost, and then you take a trace through the computation, and based on that trace, you do something that is order one, basically. Order one in the sense of you only do a fixed number of traces, but the calculation itself is on a vector basis, not full matrix by matrix. So you trace certain paths through it. And so the overall cost, could actually just be like tens of % overhead, none of this like million scale stuff. So that then tells me like, hey, if the end game of humans is that we're going to be spending all our time creating and consuming created content that either humans are generating directly or humans are like owning AI output, and it's still that kind of loop, then provenance, meaning that we're correctly tracking, how the data is coming in together with, provenance feed algorithms, and then putting the value back. Like one of the, I thought this was farther away, but I was hearing there's a team called OpenLedger, and they believe they can get a pretty accurate estimate back to like how much individual data items in the training set attributed to an answer, so that you can actually give credit back to like the creators that went into the training set. And that's an example of like a financial calculation. I think that's going to be best done with ZK. So, I think for people like prover networks like SP1, I think it's very bright possible future in that human endgame. But I think Illia had a different view of the endgame for humanity. So,
yeah, I mean, I think the question is we live in this transition period where we effectively, I would say, rolled on a 1800 technology of copyright, right? Where, Gutenberg Press was created. It effectively created this new way of distributing content, right? That went from, direct one-to-one to one-to-many. And, the copyright was created as a legal framework and incentivization framework for the creators, right? And we kind of rolled it into internet, even though it started to like break here and there. There was pirating, there was all this kind of different things because the cost of distribution effectively just plummeted, and attribution of cost of distribution became really complicated. And we fixed it up with ads and some other stuff, but like the reality is it's already been like cracking. But effectively, these AI models are completely changing how the content creation and distribution happens, right? You go from this like one creator to many, to effectively everybody can have their own model that is creating everything that humanly possible, right? So to give you an example, I can take right now a music model and I can generate every single octave that is humanly like interesting to hear, like for a human ear, right? Because the model is trained on everything and we can just like keep sampling it, and I'll give and register all of them with copyright, and everybody from now on will be violating my copyrights, right? So I think the copyright as a method and the fact of like attribution to original kind of creator, that the whole system is going to effectively go away. And I think a lot of like, I mean, we can also take a different approach, like news and photography, etc. All of this is important. But again, you have robotics, you have all these new methods as well of capturing content. So I think like there's a whole new wave of how content is created, how content is consumed that's modulated by AI. And yes, I mean, provenance is interesting, important. You do want it in social circles. But even just if you think of the open kind of internet, right, the content that's accessible to everyone, that on itself right now is kind of going to shit. Right, because effectively everywhere there's, everywhere it's open, now you have incentive either to generate a bunch of AI output or actually maliciously generating output so that the models that trained on this are then biased with whatever brand, etc. you want, right? Obviously we see this on Twitter where, a lot of bots are effectively, pulling everything in every direction possible. But this is happening on broader internet. Like every single forum is overrun by bots, every single system. So I do actually think that like open internet, as we've had it before as well, will have a lot of trouble. And we already see this, Reddits and kind of all these platforms closing up because kind of the content right now has some value that they want to sell. But I actually think that itself is gonna, in a few years, flip, because this model has now consumed all this content and you can actually sample out of it for synthetic data generation for next gen models. So I think like this transformation right now where it's like, yes, there's value still in human created content and it's used for AI, but like the provenance is, maybe we can do some attribution, although, it's hard in many cases. But like one layer from here is like actually the models are just trained now on output of a different model. Right, on output of a different model of a different model, right? So like we just keep going away from the original content, and then the models themselves will be controlling, robots and cameras and everything to like use that, and they're going to be, AIs will be transacting with people, in natural language and transactions and everything. That will be data that they use, etc. So we're kind of going away from like human to human being the main venue, and it's going to be AI to AI and AI to human as the content, and then the contribution doesn't matter as much. And so I think like we just need new ways of finding meaning in general. And I think the meaning in everything where we care about outcome is going to get automated. And so it's really going to be about the process, the interaction, sports, relationship, travel, all of those things that we care about, the kind of process of engaging in it, not the outcome of it.
Yeah, I think I'm more with Illia than Robert on this one, but I think that okay. So, how many folks here are familiar with the Pandora's box parable? It's a Greek mythology thing where Pandora is given a box. God said, "Don't open this box," and obviously she opens the box, and basically all of the evils of the world come out of the box: disease, pestilence, famine, war, conflict, and the very last thing to come out of the box is hope. Hope that that some of this stuff can be countered or overcome. And in my opinion, ZK is a bit like the hope in the AI Pandora's box, as in it's not going to be the solution, but it may be able to preserve some parts of the world that we like today. Specifically, we can use ZK to create human-centric networks where you're interacting with human beings and not AIs. For people who still like and want that. I am very skeptical that we're going to have a world where all the AI models are proved with ZK, and so that that you're not being manipulated by whatever agents are acting in your name. And I don't look at this from a technological point of view. I just look at it purely from a social point of view. Who benefits? All of the entities training foundation AI models, all the entities selling these models, but building services on top of them, they don't want you to know that the AI agent is acting purely in your interest, because it benefits them for it to not be doing that. It benefits for them to be, pushing you advertisements or manipulating your opinion in ways that you may not want. And this also goes back to the actual training sets, where that benefits people to people putting in data which is manipulated. And so take Michael and Fabric, right, and the fact that they might be able to create some custom silicon which can make proving competitive for ZK-ML. I don't doubt that. Michael is an incredibly talented person, but because of the incentives, it's basically Michael Gao and his Fabric startup versus NVIDIA. As in, if he solves this problem, AI will be 10 steps down the road and 100 times harder to prove in ZK. And where's the market for it? Because certainly it's not going to come from OpenAI deciding that they're training their models using ZK. They don't want that.
NVIDIA has confidential computing mode, and so you can actually have a
they do, but not for the user. That's a B2B product.
So this is what we're doing. We actually propagate this to the user, so you can have a full end-to-end confidential session.
You do, because
Apple's adding it as well.
Well, Apple, effectively all the M chips, which is what they run, they have confidential mode as well. So I think there is enough demand for privacy confidentiality. I think your point that right now all the models are built by companies that don't have this incentive is true. This is where actually crypto incentives create a kind of, I had this talk on Friday, a roadmap how we create a user-owned model, community-owned model, which is not owned by a company that's trying to make more money for itself. We kind of need to do that and execute on that. TEs or ZK is a tool to do that, but we actually need the actual machine learning research and development, and we need it to be recurrent in a sense that it needs to continue being state of the art. Otherwise, people will keep defaulting to whatever companies do. Yeah,
I don't want to throw shade on that because it's a worthy objective, and I hope we can put it together and do something like that. But it's tough. It's tough.
I agree. Does anybody want a last word?
Yeah, I also am actually a bit of a ZK-ML bear, I would say. I think there's very few instances where I'm using a model in my day-to-day life and I want the model to be verifiable. For example, if Cursor is, giving me a model, they're telling me they're giving me Claude Sonnet, but they're actually giving me a horrible model. I'm just going to use their competitor. And so, I don't know what value verifiability brings. I think in the global financial system, verifiability is very important on a product level, because you can prove to someone, hey, I'm not going to FTX you. And that has very clear user value. And it's very, we've all lived through that, and it's the value prop is super clear. I think the AI value prop for verifiability is a little less. I'm also somewhat bearish confidential AI as well. For example, if you looked at ChatGPT's recent memory feature, people are really happy that GPT knows more about them because they can give a better product and user experience. And in many ways, OpenAI violating your privacy, it leads to a better product. Similar to how Google can read your mind and give you ads that are better suited for you, that you're going to click and you end up buying more products that you think you want at least.
You can, actually having confidentiality means you would give it more data. You would be willing to have it hot mic if you knew this data is not going anywhere.
Okay. Can I try to close us off on hope? All right. So I forgot that part of the Pandora's box, but I love that. So on the hope side, I will say just 2 words, feed algorithm. That tells me that I want verifiable ML. And on privacy, if you give people the same quality experience, everyone will choose for it to be private. So that's an optimistic thing. And on copyrights and the bots, I think that the courts actually got something right. I don't know if people are aware that courts declared that purely AI-generated information can't be, output can't be copyrighted. But if a human says that they used AI to create something, it can be copyrighted or owned. And, I think there's this point which, is this being recorded? Yes. Shit. Okay, I'm going to say this, but our AI overlords later are going to, they're going to give me a demerit for this. I think it is a good thing for AIs to actually be paired with humans. And so even if AI is generating billions of things and bots and everything else, if there is a provenance of bots to a human, right, and if we don't allow bots that are just raw data that have no provenance to a person, that gives us some control. Like, you know, if there's a person out there that is generating 1 million times more output than me, then when I produce something, it should have a higher intrinsic value because I'm not spamming myself to death. I'm showing people that I'm restricting how much I'm saying, like Uma. Sorry, am I saying it Uma or Uma? Uma. Okay, sorry. I just realized I'm probably mispronouncing it. Like, I call you Zaki, and I'm like, it's supposed to be Zaki. Anyway, I don't remember what the 2 words were that you closed off the other section where I was pointing out that, like, you know, in terms of impact per word, you won that round. But, you know, I think that, you know, saying fewer things and him having more value is, like, inherently good. It, you know, maximizes the value of attention.
All right. Thank you very much, guys.
All right.